Glass fiber reinforced concrete cladding, the solution of choice for shaping the future. Glass fiber reinforced concrete, GFRC, has become a familiar product to the construction industry. One of the most innovative materials available, GFRC facilitates unprecedented opportunities for design of the most visible element of a structure, its cladding. GFRC is rapidly becoming the material of choice for a broad range of building types. GFRC is a Portland cement-based composite reinforced with randomly dispersed alkali-resistant glass fibers. The fibers serve a purpose similar to the reinforcing steel in reinforced concrete. The glass fibers add flexural, tensile, and impact strengths, allowing the production of strong, thin, lightweight architectural cladding panels for all types of buildings. GFRC was first introduced to the world's building industry in 1969, starting in the United Kingdom and Europe and closely followed by the US, Middle East, and Southeast Asia. It boasts over 30 years of proven performance. GFRC is a quality material with initial plasticity that is incredibly responsive to the designer's creative needs. Designers can choose from a variety of sculptured shapes, from reveals to complex rectilinear and curvilinear shapes, such as short radius curves, wide sweeping arcs, or 90-degree angles with minimal effect on panel cost. Optimum economy occurs, however, when reuse of forms is maximized with product repetition. Not only can traditional architectural styles or intricate ornamental details be faithfully reproduced, but also complex surface designs or profiles can be incorporated in either relief or intaglio. The shape and final finish of a building when using glass fiber reinforced concrete is limited only by the architect's imagination. GFRC's increasing popularity results from the manufacturer's ability to meet demands for more sophisticated custom-designed solutions. Architects are designing creative facades by taking full advantage of the wide variety of GFRC components available. These include solid walls and window wall units, spandrels, cornices, interior ceiling panels, columns, soffits, fascias, domes, and mullions. Versatile GFRC can also be used as mansard roofs and interior feature panels. The sculptured shapes that are possible with GFRC window wall panels allow for the design of many types of shading devices for window areas, including vertical and horizontal shades. For example, profiled window wall units can form deeply recessed window frames that provide a high degree of sun shading and minimal solar heat gain without reducing natural light and view. GFRC is manufactured by simultaneously hand-spraying a Portland cement sand admixture slurry and glass fibers into forms of the desired shape and size. The slurry is mixed in a high-shear mixer and fed via a pump to a concentric spray gun, which chops the glass fiber strands into approximately 1 1/2 inch lengths and injects them into the slurry. The GFRC skin has two distinct layers, a mist or face coat and backup layers. The mist coat, consisting of a cement sand slurry, may be sprayed on first to provide cover for the glass fibers on the finished face. Consolidation of the face coat is done to remove any entrapped air and to impart a void-free face surface. Prior to initial set of the mist or face coat, the GFRC backup is sprayed. Several layers of the composite are deposited and compacted until the required backup thickness, usually 1/2 to 3/4 inch, is achieved. Consolidation between layers is done with rollers, which compact the backup mix, remove entrapped air, and bond the face mix to the backup glass fiber mix. Quality control checks on thickness are made regularly during the spraying operation to ensure a uniform thickness of the finished panel. Molds into which GFRC are sprayed can be made of plywood, concrete, steel, plastic, polyester resins reinforced with glass fibers, plaster, foam plastic, GFRC, rubber, or a combination of these materials. The molds are responsible for giving the panels their final shapes. Fabrication economy is determined primarily by the extent of casting repetition and by the piece sizes, particularly if the molds have shape. Glass fiber reinforced concrete manufacturers have responded to the desire for more color choices by offering a wide variety of colorful ingredients. Color variations are achieved through selection of Portland cement, color pigments, or different colored aggregates. Throughout manufacture, stringent quality control procedures assure proper spray rates of slurry and fiber. The slurry flow rate, bucket test, and the fiber roving chopping rate, bag test, are used to determine if the fiber content being sprayed is within limits. Sample coupons are prepared in order to perform fiber content tests or washout tests. Cured coupons are used to determine bulk density, absorption, and flexural strength. Typically, reinforcement of the skin is required for panels of appreciable size. These stiffeners can be a single skin rib or a box rib. Plant-attached frames comprised of steel studs or structural tubes are the most common and economical method for stiffening. These frames also provide a means for connecting to the building structure. Prior to the manufacturing of the panel, a frame of light-gauge steel stud or structural tube is welded. The frame is positioned over the GFRC skin as soon as the skin has been sprayed to the proper thickness. L-shaped flex anchors, pre-attached to the frame by welding, are attached to the skin with additional GFRC material known as bonding pads. The flex anchor enables the GFRC skin to move slightly to compensate for thermal and moisture movement of the GFRC face without undue restraint from the frame. Sometimes gravity anchors positioned along the bottom of the panel are used in addition to the flex anchors. This added support helps to transfer the weight of the skin to the steel frame. Gravity anchors may be trussed round bars or flat bar tees welded to the frame and attached to the GFRC skin in a manner similar to flex anchor attachments. The following morning, after the GFRC panels meet a required minimum strength, the panels are demolded or stripped from their molds. The panels are then moved to the finishing area and the molds are reassembled as the daily process starts again. GFRC panels can be customized in virtually any color, form, or texture to meet aesthetic and practical requirements of modern architecture. Since GFRC is sprayed on the form, a consistent texture can be achieved on highly articulated profiles. Unlike other materials, GFRC offers excellent possibilities for the architectural use of multiple colors and textures. The fine matrix of GFRC allows production of delicately detailed surface patterns in low relief at reasonable cost. It is also able to reproduce the appearance of natural stone, terracotta, and even metal panels. Panel finishes can be achieved by sandblasting, water blasting, or other techniques. After finishing, panels are stored until shipment to the project site is required. Also, natural stone veneers may be used in creating an almost infinite number of patterns. Thin veneers of natural stone are panelized utilizing the GFRC skin and frame for support, resulting in ease of transportation and installation. A major benefit of the lightweight GFRC panels is the ability to ship many panels on a single load. This allows for economical transportation over long distances. Panels can be cast in sizes up to approximately 12 by 30 feet. That limitation arises not from structural restraints, but from transportation logistics. On single large steel frames, the continuous GFRC skin should span no more than 20 feet without including a skin joint. After panel installation, window frames are screw attached to head and sill members of the panel frame or to a separate framing system. The frames also provide a cavity for installing insulation, fire safing, and utility conduits. Drywall can be mounted on furring channels attached to the panel frames. Today, GFRC is used to clad a wide range of structures from single-story buildings to skyscrapers. A building's exterior creates a visitor's strongest impression and a company's most enduring image. Shown here are some of the thousands of buildings in all climatic conditions with unique distinctive facades that have been created with glass fiber reinforced concrete. The exterior cladding of the San Francisco Towers, an upscale retirement community, features GFRC panels which are designed to reflect local architecture. Some of the main features are bay windows, several different cornice shapes, arches and keystones, recessed windows, mansard roofs, and dormers. Architect Ralph Butterfield, president of Worcester, Bernardi, and Edmonds Architects.
We needed something that had a lot of potential for decoration and for a lot of ins and out and changes of color, changes of texture. And the natural choice was GFRC, which gave us that. We were able to work with the GFRC manufacturer to come up with innovations that allowed us to cast multiple color panels that would allow some of the Victorian details that we wanted to achieve. There are many different forms in the project: intricate cornices, belt courses, bay windows, panelized spandrels, and arches and very deep reveals on the 2 ground level floors. And in the end, we had a very successful project in terms of keeping on schedule and getting this up at the proper time, which was very important.
Baltimore-based architectural engineering firm RTKL Associates designed the Operations Center campus for T. Rowe Price in Owings Mills, Maryland. RTKL project manager Stephen Empey.
RTKL has used GFRC, or glass fiber reinforced concrete, as part of its material vocabulary for the better part of 15 years. Originally, we did a project in San Antonio for the Marriott Corporation, a high-rise hotel, and we used GFRC as the predominant cladding material. Since then, we've also used it in smaller applications, in cornices and medallions, and particularly in historic renovation. My current project, the T. Rowe Price Financial Center, is a good example of why we would select GFRC as a material. First of all, T. Rowe Price being a financial services institution, they were looking for a traditional design. And by using GFRC as concrete along with the brick and traditional precast concrete that we have on the rest of the building, this satisfied that requirement. Where GFRC became particularly an advantage to us was using it as the cornice on the top of the building. It was much lighter in weight than the traditional precast, say 15 pounds per square foot instead of about 130, and we were able to take that lighter weight and lighten up the steel design. And also, since GFRC comes prefabricated with a steel stud backup, we were able to improve and simplify the connection design onto that steel frame. RTKL has realized several advantages when we're designing GFRC and working with a PCI certified plant. First of all, we always get good color control and we get uniformity in the material. Best of all, though, we get early involvement from the fabricator and his engineers who come into our studio and work with us, aiding us in the design of the material, helping us establish joint patterns and spacings, and also help us to do the connection design so that it not only suits our design purposes, but also optimizes his efficiencies in the plant. This is always a valuable service that not only pays for us, but also to the owner.
GFRC panels place a lighter load on the structural framing and foundation of buildings, offering potential savings in multi-story construction and in construction on poor supporting soil. As an example, 150 tons less structural steel was used in construction of the downtown Marriott Hotel in San Francisco, compared to what would have been required for precast concrete cladding. The light weight also can be exploited on low-rise buildings where heavier cladding systems would require larger framing members. GFRC is ideal for recladding projects. Its light weight minimizes the load added to the existing structure. Its design flexibility in color, texture, pattern, and surface finish allows it to blend with other construction materials. Exact GFRC replicas of intricate ornamental work from historical buildings are virtually indistinguishable from the original. Mold impressions taken from existing ornaments can be reworked and extended to match required dimensions. GFRC is a less expensive and faster construction alternative to handset terracotta. There are many advantages in using GFRC in addition to its light weight. These include unequal design freedom, function, and economy. GFRC delivers aesthetics with greater design flexibility than any other exterior cladding material. GFRC offers design freedom in its capability to be molded into most any shape. A wide variety of uniform surface finishes are available and a variety of colors can be attained. Multiple colors and textures can be obtained in the same panel. Also, one-of-a-kind patterns are available. GFRC functionality is augmented by guaranteed high quality through PCI plant certification. Producers must commit to substantial investments in training and plant facilities. Then they must undergo unannounced and exhausting inspections conducted by thorough, independent certification engineers. GFRC systems have superior energy efficiency and can be designed for the various degrees of sound and fire resistance required by building codes. GFRC is highly durable with very low maintenance. It's an environmentally friendly material. GFRC's economic advantages include low cost, making GFRC an excellent value. Installation is quick, allowing for earlier occupancy. Construction can take place in all types of weather conditions. GFRC can incorporate or simulate many other types of materials. Its sources are widely available, also including early design assistance and budget pricing services. The advantages of using GFRC can be enhanced when the entire design team has the opportunity to jointly develop a project from the initial design stage. Time spent in development pays off in accelerated construction and significant cost savings. Therefore, it is recommended that the designer seek assistance from their local GFRC producer in the early design stages. Through a coordinated team effort, maximum economy and optimum quality can be achieved. Measurable economic advantages make GFRC the solution of choice for shaping the future. For more information on glass fiber reinforced concrete, write the Precast Pre-Stressed Concrete Institute, 209 West Jackson Boulevard, Suite 500, Chicago, Illinois, 60606, or contact your local PCI member GFRC producer.